welcome to Mathelingual. It's been a few weeks, but that's what happens when you have a couple midterms in recent days or recent weeks. Yeah. Okay, so anyway, this week, this video, we're going to focus on, well, we talked about inequalities a bit last time, more of like a preview into inequalities, like introduction and the expressions, you know, changing the words into actual like algebraic expressions. Now we're going to dive deep into some properties of the real inequalities. So first, let me clean this out. I've had this written on this side of the whiteboard for weeks, and I don't plan on erasing it because it just kept me really motivated, and that's good when you have exams. Okay, so one key thing I want to make a point about first off on inequalities is that similar to the properties of equations and expressions, you know, we're going to have the same kind of addition and subtraction properties, but there is a key difference when you're working with inequalities. Inequalities, when it involves multiplication or division by a negative number, you are going to have to flip the inequality sign. So you'll see what I mean in a little bit once we go over some of these rules. Okay, so for these rules, we're going to assume that A, B, and C are real numbers, okay? So we're going to assume they are real numbers. So first up, we've got the transitive property. This may sound familiar from when we were working back with properties of, properties of real numbers, I believe. Let me see. Yeah, I think properties of real numbers, well, something similar, but the key is transitive. Transitive property means if A is greater than B and B is greater than C, then we can say that A is greater than C. Okay, so like here's an example. 5 is greater than 3, right? And 3 is greater than 1. So we can say 5 is greater than 1. You see? Because they both involve this number, so you can go straight to comparing those two directly. So that's what it means. Okay, next property, the addition property. Addition property. So if A is greater than B, then A plus C is going to be greater than B plus C, right? Because whatever you do to one side of the inequality, like with equations, whatever you do to one side, you've got to do to the other to keep it balanced, okay? So let's look at an example. 4 is greater than 1, so we know that 4 plus 2 must be greater than 1 plus 2, okay? Because although you're adding the same amount to each number, this one is the bigger number. So ultimately this sum is going to be bigger as well. Okay, next one, subtraction. So this works in a very similar way. It states that if A is greater than B, then A minus C is going to be greater than B minus C. So let's look at an example. 7 is greater than 4, so 7 minus 3 is going to be greater than 4 minus 3, because again, you are doing the same kind of operation to both sides of the inequality, but that doesn't change the fact that this number, 7, is bigger than 4. Therefore, your difference is going to be bigger when it involves the bigger number. All right, now, pay attention carefully. This is the multiplication and division I was making a note on earlier. I'm just going to split this up into two sections because they're very related, obviously because they're inverse operations to each other, but they are the key parts of these inequality properties. So, multiplication. If A is greater than B and C is greater than 0, do not forget this, because remember, you multiply anything by 0, you're just going to get 0. Because you're basically asking, for instance, I have this many groups of 0. What? 0 is nothing. You can't have some groups of 0. You can't have some groups of nothing. You just have nothing. Okay, so for multiplication, if A is greater than B and C is greater than 0, then A times C, right, we can just write the letters like that, A times C is going to be greater than A times B, okay? Or if A is greater than B and C is less than 0, so it's going to be a negative number, actually, A times C is going to be less than A times B, okay? So let's look at an example of this down here. You can still see this, but I'm trying to enunciate what I'm saying just in case. Okay, so let's say you have 6 is greater than 5. So we know that if 6 is greater than 5, that means 6 times 3 must be greater than 5 times 3, okay? But if 6 is greater than 5, but 6 times negative 2 is going to be less than 5 times negative 2. Why? Because when you look at these two, 6 times negative 2 is negative 12, and 5 times negative 2 is negative 10. When we say bigger number, you think about it like this. The bigger number is going to be less negative. Okay, so in this case, negative 10 is less negative than negative 12. So we say negative 10 is the bigger amount, right? It is more, it's not positive, but it is more close, it's closer to positive than negative 12. It's less negative. Negative 10 is less negative. So that is why we have to flip the sign. And you'll see in a moment, this is also the case for division. So with division, we have the same basic rules. If A is greater than B and C is greater than 0, then A divided by C is greater than B divided by C. But if A is greater than B and C is less than 0, right, it's going to be negative, then you've got to flip the sign, because then A divided by C is going to be less than B divided by C. So let's look at an example of the division property, okay? So let's say that we know 9 is greater than 3. So 9 divided by 3 is going to be greater than 3 divided by 3, right? Because you've got 9 divided by 3 is 3. 3 divided by 3 is 1. 3 is obviously bigger than 1. But when you throw in a negative number, that's when things get a little wonky, I guess. So let's say, I'm just going to do an example. Let's say we did 9 divided by negative 1. That is going to be less than 3 divided by negative 1, because you're going to have negative 9 versus negative 3. And remember, when we talk about a bigger amount with these kinds of problems, the bigger number is going to be less negative. So negative 3 is less negative than negative 9. So therefore, we say negative 9 is less than negative 3. Okay? So that's basically just the main properties of inequalities. So all in all, not too different from properties we have talked about. Okay, I found the page. Properties of equality. That's what also had the transitive property. So you see, really, the basic concept of these properties, their names, for instance, are really universal, no matter what kind of algebra you're working with, be it inequalities or equalities. But the key difference here is these two at the bottom, multiplication and division. Do not overlook that, because it does matter a lot in inequalities. Okay, so that wraps it up for this video. Till next time, I'm Maya, and this has been Mathelingual.